What you see on the screen now is the safe harbor statement, which serves as a reminder that this advisor webcast is intended for information purposes only. Any features or functionalities described for Oracle's products remains at the sole discretion of Oracle. Now, let's get started with our presentation. Fred, if you're ready, I'll turn the webcast over to you, and you can begin.
Thank you, Sharonda. And again, my name is Fred Hubert, Program Manager with the Siebel Center of Expertise over here at Oracle. I hope everyone can hear me all right. I do want to get started here with troubleshooting performance issues with SARM. And Sharonda, thanks for the kind words. I have actually been working with Oracle, and prior to that with Siebel Systems since about 2001, and have been working with a Siebel application since 1998 as a consultant, implementing the application as well as moving into the training role. Some of you may have attended Siebel Essentials or the consultant course, integration, or other training that I offered over the years. And then a transition over here to the support side as well, where we're really working with a number of different tools to try to get some improved customer sat over with a variety of different opportunities that can help us to either collect better data, provide better information back to customers, or help to more quickly diagnose issues. And SARM, I really am a big believer in this tool. If I could pick one area where there's just a fantastic set of tooling and there's a very limited understanding out in the field, this would certainly be it. Really some great things that we can do here. I know a lot of people here may already have some idea of what SARM is. I do want to make sure everyone in here understands what the tool is intended for, as well as how to collect SARM files for performance issues, convert those SARM files over to a format like CSV so that we can analyze the data if needed to. We can also understand that SARM data and its structure, and also use post-processing tools like SARMQuery to quickly find the root cause of a performance issue. With that said, SARM, also known as Siebel ARM, also known as Siebel Application Response Measurement, and I've heard also Siebel Application Response Management, is really implemented as the ARM standard within the Siebel application. What I mean by that is ARM is a standard for application response measurement and collecting data in environments where we want to try to capture transactional data that may be happening very frequently and very quickly. And we want to be able to try to collect a minimal amount of data there so that we can quickly understand what's going on at a performance standpoint, but also not bog down the application by using those diagnostics. And so the ARM standard is really intended to give us a lightweight, scalable tool that can be built into a production environment or into a dev or QA type environment to quickly measure response time, CPU, and memory utilization. And so Siebel ARM, or SARM, is the framework that we've implemented into the Siebel application so that we can capture performance data specifically on the Siebel server and Siebel web server extension. We then have post-processing tools, as I mentioned before, to quickly analyze that SARM data. Those post-processing tools have changed a bit over the years. Some of you may have actually worked with SARM Analyzer, either with the SARM tool itself or also with the Flight Data Recorder. SARM Analyzer was originally released in Siebel 753, and it was the original command line tool that we used to convert SARM files over to XML or CSV, and we still, to this day, use it with Flight Data Recorder data as well. They really piggyback off of one another very neatly. SARM Analyzer is a nice tool for capturing that data, but one of the real downfalls was that it loaded the entire binary file that we used, that whole SARM file with all of our memory and consumption data, into memory, and then began its conversion process. So we could do some very lightweight manipulation of the data in memory, but it was very time-consuming. It was a lot of effort for the SARM Analyzer tool to be able to process the data. And so with Siebel 7.7, and in subsequent versions since then, we've rolled out SARMQuery. And SARMQuery is really a command line tool specifically built to, one, load that data into memory, but two, do it in a much more dynamic way so that we can parse through the data and only need to load into memory the data we intend to use. Also important with SARMQuery is that we can use some query-like syntax or SQL-like syntax to go through, filter, and aggregate our data, to try to trace the parent-child relationships between different transactions. For example, I went to this applet which caused us to query this business component, which executed this script, which piece there was the slow-performing area of the application. And I can try to figure out exactly which one it was, and I can see that full tree of information information that was spawning off of the initial transaction and the performance that was associated with each. And also be able to then output it over to formats that are human readable as well. SARMQuery was originally released for 7.7, 7.8, and still exists out there. The tool that you use in those cases is called SARMQuery 7.8.exe. For 8.0 and active, we use a tool called SARMQuery.exe. It's really the same type of tool. The only major difference is that the formatting of the data that we collect is a little bit different, and the way that we gather those diagnostics is somewhat improved with a little bit different naming conventions for the files that we work with, and a slightly improved way of actually storing the data in the both binary and also output formats that might work with. So I'll talk a little bit more about that as we go. But from there, SARM Instrumentation is kind of built into different parts of the application. As you can imagine, the key milestones in the code, as engineers are building the application code that is the Siebel application, at key milestones we then say, okay, at this point, if SARM has been enabled, then we will write something out to our SARM file. And we can very quickly make that binary decision, should we write something out or not for this transaction, and very quickly publish out to a binary file just a quick word of text or a quick word of ones and zeros that represent each transaction as they go. And those areas where this has been written include things like your web server time, which is the actual time spent on the web server with the Siebel web server extension. Your infra-network time, so that we can capture the time it takes from web server to Siebel server, which can certainly be a big piece. Also your Siebel server time, database time, and application-specific time. And we'll talk about some of those things as we go. I'll give you a couple of examples. On the web server, and on most of our transactions, we're going to be looking on the Siebel server side. But on the web server, within our Siebel web server extensions, we may be interested in the actual login session, the time it takes to send a message to the Siebel server and receive a request back. We may be looking to see if there's a bottleneck of sorts over here. And your web server then publishes out to a separate set of log files on the local machine, those SARM files that we can look at. On your Siebel server, we also will generate a separate set of SARM files over here. And those SARM files might include your the receipt of the request from the web server, or for a workflow, we might be invoking a particular workflow step. We might have an object manager where we are logging in as a user. We're performing a query, creating a new record or saving a record. On the database side, we might take the time to prepare, execute, and then fetch results from the database or perform a write to the database. And all of those types of transactions can be captured. And we'll talk in more detail about what those transactions will look like in subsequent slides. That SARM data collection then is collected into a memory buffer during application processing. Instead of opening up a file and then writing to the file and then letting go of the file and then opening up again, what we do instead is we hold that data in a memory buffer, and then when that buffer gets to a certain size, or alternately, when a specified time period elapses on the Siebel server, we can then flush that buffer out to a SARM file, and after that data's been flushed to buffer, we may then start to begin a new memory buffer with a new set of transactions, which is going to take up only the memory for the new transactions. In other words, we'll flush out the subsequent data. Now, at some point, we may choose a maximum file size, and once we reach that maximum file size, we can then create another SARM file once we've reached that. So there's always one and only one active SARM file. We may have many SARM files logged on the disk as a kind of an archive of that past event. And I'll show you how we define each one of those things. Those SARM files then are stored in your log directory on your Siebel server or on the web server where you've installed the Siebel web server extension. And their file names have the following format. For 8.0, there's a letter code, and then your component name. And that letter code might be A for application server or W for web server. Your component name, you can see over here, SCC_OPT_MGR_EMU. That's the Siebel Call Center Object Manager for U.S. English. Then a timestamp, and it's actually a T timestamp. You can see T, and this is actually a very old screenshot, as you can see, 2006, and it's November 15th, 2006, at 10:36. Then we have a process ID. This is the actual PID on that machine. And then N0001.SARM. That was the first SARM file that was generated, actually the second, it starts at N0000, and then we increment it to N0001, N0002, as we create new SARM files, all the way up to N99999, and then we begin with 000 again. And in that way, we can ensure that it's highly unlikely that you'd ever overwrite meaningfully archived SARM data that you intended to go back and get at some point. In 7.7 or 7.8, the timestamp looks a little bit different. It's the same type of naming convention as key timestamp, underscore process ID, underscore file number. But we don't have that letter code. We don't have the component name up front. We don't have quite the same naming convention, so it is a little bit different. Now, those SARM files, the binary files, are not intended for human consumption, and the ones and zeros in there are not meaningful for us to read. However, you can query that data out, and we'll talk a little bit about how as we go using the SARMQuery tool. Now, in its most basic format, you can extract that data out by saying, I want to run SARMQuery, and we've installed SARMQuery over here in its own directory. Note that you don't have to do that. That's actually, in Siebel 8, it's actually installed along with your Siebel server in your Siebel server bin directory. But in this case, in the 8.0 SARMQuery directory on my D drive, we installed in the bin directory, we have SARMQuery.exe, and we run SARMQuery with some flags, just like you would with other applications you may have used. If you've worked with Server Manager or other tools within Siebel, you've certainly seen this as well. SARMQuery-select. So what are we going to be selecting out? And I can choose exactly what we want to collect out of that SARM file. So there might be more data in there than I want. I might want to perform some type of filter that only brings back certain records. In this case, I don't. I'm going to get the whole tree. Tree equals all. So get everything from top to bottom in that whole tree of calls that may be in my SARM data. And then dash input, it begs the question, what SARM files am I looking at? And you can either choose a specific file name, or you can choose a directory. In my case, I chose D:/A, Siebel Call Center Object Manager, EMU for T 2009. So this is, again, an older SARM file for process number 20130 is N0001.SARM. That was the second SARM file generated on that machine, not N0000.SARM. So that was the SARM file I chose. And I want to output -O that data as SARM data over to D:/myfile.csv. So if you're going to pick a slide that you were interested in over here, if you want to pull down the slide deck later on and take a look back at this one in particular, this is just a quick way to be able to dump all the data out to a CSV file. And sure enough, you can see the plan execution time took about 3 seconds to dump it out, exited successfully. Congratulations, you can now look at that data. And that data looks something like this. You can see up here, and I've bolded these just to make it a little bit more readable. I use a standard spreadsheet tool. I encourage you to try to find one that may be a good fit for you. I'm certain that there are many people who use different spreadsheet tools out there. In this case, I believe this may be Microsoft Excel. Here we have start time, end time, SARM ID, search ID, parent ID, root ID, depth, area, sub-area, and instance name. There's actually quite a few more than these fields over here. But that's start time and end time on my transaction. Note that each one of these is one distinct transaction, and a very granular distinct transaction that we can see in here. I'll talk about how granular it was later on. Each one of these transactions has a start time and an end time and a unique identifier, 46861, 46862, 46863, and so on. That sequentially numbered SARM ID, as well as a search ID, which is actually concatenated data, including that SARM ID and more, a parent ID and a root ID, and I'll talk about those in a moment, as well as a depth, how far down the tree is this particular transaction. So you can see a top-level transaction has a child that has a grandchild with a great-grandchild and a great-great-grandchild, and even great-great-great-great. I don't know how many greats there are, but way down the list down there, we can see all that level of relationship in there. The more interesting parts in here, though, are the area, the sub-area, and instance name, where I can see, for example, that we were performing some type of interaction over here with the Object Manager. Specifically, in Object Manager, we were performing a business component, write record, into the service request business component. So we were saving a record in the SR business component. Now, what we were doing, how were we we saving it? Why were we saving it? That I can't see right here, but this transaction was executed. We can see the time that it took, and we can also see additional data about that. When we look at that data, start time, end time, area, sub-area, instance name, and detail are going to give us more information about the event itself. In this case, we can see area and sub-area, for example, object manager and business component write record. But the instance name that we see over here is descriptive of which business component we're writing a record to. Oh, we're saving a record in the service request business component. You may also see, in addition to instance name, detail. And that could be useful if we were looking at an event where we were describing that we were invoking a method, and it begs the question, which method were we invoking? For example, if you're in an applet and you click on a button, you can probably guess from the label of the button which method it will invoke. For example, if I click on the new button, it invokes the method called new record. If I click on the delete button, it invokes the method called delete record. In some cases, it's not a one-to-one match. For example, if I were to right-click, save a record, or use Control-F, it invokes the method called write record, not save record. And so when I look at that, the detail describes that particular event in more detail. I can also see, in some cases, for some types of transactions, the username that was actually doing this. There are some cases where that transactional level information is not appropriate. And then also response time and self-response time, where we can see the actual time that the transaction took, which in some ways you can think of as being end time minus start time. Although you can see here, it started at 2:30 and ended at 2:30 in the afternoon. Nothing changed. So how long does that take? Well, that's not very granular. That's telling us that it took less than a minute. So it really doesn't give me a lot of detail. Your response time is going to be measured in milliseconds. And actually, more specifically, we can break that into response time for this transaction and all of the things underneath it, as well as the self-response time. For example, when we go to build this applet, how long does it take to build the applet? Would be the self-response time. How long does it take to build the applet? And also that involves getting data from the business component, which means we have to perform a database query, which means we have to prepare, execute, and then fetch a result set from the database, and possibly more than one. And we bring all that data back. How long does that whole transaction take? The response time is the total sum of those transactions. The self-response time is the time spent for that one transaction only. So as I said before, we can get pretty granular with that. And what's nice here is that that data then is also related within the data structure here. You might remember that I talked about kind of a depth, that level of detail that we're looking at over here. Well, the SARM data is hierarchically structured, and we use that hierarchy to then describe the total time for some of these transactions and be able to relate them to one another. And so what I can see over here is we've had an infra entry. This is an infra network time or an infra call that was being made. In other words, the web server was saying, hey, object manager, I want you to do something. And why does it do that? Most likely the user clicked on something. Maybe they tried to navigate to a view. They clicked on a drill down. Maybe they clicked on a button or they were doing something else in the application. Whatever it may be that they were doing, that may have called the web server, which in turn called our object manager. Ultimately, it could be that there's some application functionality that's being performed on behalf of the user, but not based on a specific user interaction. And that, too, could make a call come from the application up to the web server, ultimately up to the object manager. So when that call comes in, we can see that the user who is logged in was admin. And that specific call, the self-response time, was just under 3 milliseconds. However, the total response time for this transaction was over 1.4 total seconds. And so you can see, what was that transaction? Well, transaction number 46861 is kind of the root level. It has a depth of 1. It's the highest level transaction. It was the initial transaction that invoked this. There are many children of this transaction. For example, one of them is that we have 46862, which has a parent of 46861, the same one we were looking at, and also a root of 46861, the same we were looking at. It has a depth of 2, in other words, it's a child of that parent. And we're calling the object manager, which invoked a business service called the web engine interface. In other words, the call was made, and it was talking to the Siebel web engine portion of the object manager, the user interface piece. the part that understands how end users interact with the application, how they click on things, invoke methods using applets, they click on buttons, or they drill down on hyperlinks, or whatever else it might be. It's the web engine interface within Siebel that actually interprets those transactions that are being called by end users and pushes that data back. For the most part, we're not interested in what the web engine interface is doing. Instead, we're interested in the fact that when this call came in, the web engine interface took it in less than a millisecond, handed it back over to the next piece where we're doing the Siebel web engine, was performing some type of user authentication over here. And that user authentication, again, took just over a millisecond, and you can see that there was some authentication ID that was being passed in, which we used to verify this transaction really was coming from your web server and ultimately from an end user who was passing that data up. And so we do have some authentication over there to ensure that we aren't getting spoofed by some malicious user who is intending to try to trick us into performing a transaction that we shouldn't. Next, we can see sweep page. This is the first transaction that you or I really think of. What do they do? In this case, they went to a view. So sweep page view build, they went over to the My Service Request List view, or you and I might know it as a Personal Service Request List view. If you go into Siebel Tools, or if you go up to Help About View in the application, you'll see Personal Service Request List view. That's the name of the view that was built, and that one took a little longer. The total time for that was 1.25 seconds. Actually, the self-response time just to build that view was 43 milliseconds. Now we're starting to see some of the things that were there. And in fact, if I were to then blow that up a little bit, you can see that transaction where we're building the view, 46864. Then it has, as a parent, it has 46863, and as a root, 46861, the initial transaction that called this whole thing. And so you can kind of see how all those things are interrelated using those SARM IDs. Moreover, you can see that that view, three-page view build, then caused us to look at the state model so that we can control the flow of a record. For example, maybe a service request can only go from open to pending, then pending to closed, but it can't go directly from open to closed. Then it can go to open to canceled, but we can't reopen it right away. So you have to load into memory any state model cache that was there for service requests. And also we had to build our service request list applet. And so you can see here we have a sweep page applet build that took 275 of those milliseconds. So now we're starting to see where this came from. 275 of those 1250 milliseconds that we had were spent just building the form applet or the detail applet over here. And then the other applet actually took a very short time. It only took a few milliseconds to build the service request list applet once we'd done it. And then our last transaction over here, we had another 175 of those milliseconds on our three-page view show. We're actually ultimately not just building the view, but actually rendering it back into a page that could ultimately be passed back to the web server and rendered in the user interface for the end user. And so you can see all those transactions. Now, I'm probably not interested in why it took 175 versus 172 milliseconds to perform these. What I'm looking for is outliers. Where are some of these things that are causing problems coming from? And there's a number of things I can look at. The response time and self-response time are certainly some of them. We can also look at percent CPU and CPU time, system memory and bytes. We can take a look at the host name, our server and component name that we were looking at, and some other data in here. All of those things are captured in the transaction. Interestingly enough, your Siebel ARM data or SARM data is also represented in our log files. Siebel log files will contain SARM IDs in some cases, where we can then match that up to timing data. Not only may they contain SARM IDs, you can actually see SQL statements in there may contain SARM IDs. And so in our SQL, we may have a SARM ID, and in our SARM data, we can see that SARM ID, and we can see then that this SQL was generated for that business component. And we can marry the two up together in a more meaningful way. Especially if we see that a lot of different SQL statements are being executed. They were all the same, but this one time it took a little longer. It looked the same. I can't figure out what was different about this one time. I think I can marry those two up and try to look not only at the SQL statement, but also at the SARM data that goes along with it to try to figure out which user, which view they were in, or other actions that they performed recently which may have caused a problem. Maybe there's a workflow or script or something else that was being executed at just some more time. to ultimately give us the performance issue that we encountered. And so you can relate your SARM data back to your log files through those SARM IDs. You can also see the operating system process IDs. You can marry these up as well, so you can make sure that you're looking at the same SARM file and log file data that match up to one another. So there's some good things that we can do there. Now, I mentioned before that SARM data has to be turned on. You have to enable SARM in order to make it begin collecting data. And the way that we do that is through a single parameter called SARM granularity level. The SARM granularity level is a parameter that can be set either on your Siebel server or for specific components on the Siebel server for which SARM has been enabled. For example, your object manager. There are other components, especially object manager-based components like workflow, that can also use these SARM parameters. If you take a look at SARM granularity level, SARM granularity level can be set to 0, 1, or 2. 0, the default, is disabled. We're not going to write anything out. We're not going to capture performance data. I can change that to 1, performance tuning, which will capture transactions at a high level, but it may not get into a detail level. Or I can get into SARM granularity level of 2, which captures more data, but the performance impact can be non-trivial. Performance tuning level, that SARM granularity level of 1, will give us a good idea of the major things that are going on, the views that we're going to do. You can see at a high level what you're doing in the application. We are running workflows, but we can't necessarily get into the level of detail of the name of the script that we were running here or the specific business component transaction that was being performed over here. We don't capture quite as much data. And so the reason that SARM granularity level of 1 exists is really not to be able to try to do detailed troubleshooting, but instead as kind of a baseline understanding of how the application should work. And in fact, the performance impact for SARM granularity level of 1 is less than a 5% hit on your performance across the board. And so in a lot of cases, we may actually recommend that you gather kind of a baseline of that SARM data by setting this to 1, even in a production environment, but not to 2. The performance impact for SARM granularity level of 2 is significant and could really cause more problems than you're solving. When we're trying to look at our performance, and we're trying to figure out why are things slow, the answer you'd least like to see is because we were looking at our performance. And so we really want to be careful that we're not bogging down the server by capturing more performance data than we need. When changing the SARM granularity level, those changes are immediate and don't require restarting your server or components. However, it's worth noting that new tasks, once they start up, will only learn what their SARM level is at startup. In other words, if I set the SARM granularity level to 2, I then log into my object manager and start up a brand new task for this user who's logged in. There's a new session for me. I'm logged in, I'm doing things, and then I set the SARM granularity level back down to 0. That task that's still running for me in the background, that's still performing all the regular object managery stuff that you would expect, is going to still be running with a SARM granularity level of 2, even though I've since turned it down, because it will continue to do that until I log out or time out. And so new tasks, we use the new SARM level. Existing tasks continue to use the old SARM level until you close out that task. There are other parameters also that can be set to control your SARM behavior. Your SARM buffer size. How large should we allow that buffer in memory to get? And the bigger you allow it to get, the good thing is we don't have to flush stuff out to file as often. The bad news is that we're holding up more memory. And so if we have a machine that may be memory bound, it may be a good idea to turn down this SARM buffer size. In a lot of cases, that's not necessary, but it may be useful. And the SARM period can also be used. Instead of choosing a buffer size, we can instead say, I want you to, every 3 minutes, I want you to flush data out to memory, or from memory out to file. In this case, we're saying, the SARM buffer size, once we get up to 500,000, or once we get up to half a meg worth of buffer over here, let's flush it out to the file. And then our SARM data file size, what's the maximum file size before we then close out and create a new file? And so in this case, it's 1.5 megs. And so we'll let the buffer get up to half a meg, flush it to file. Let the buffer get up to half a meg, flush it to file. Now that file's up to a meg. Let it go up to half a meg again, flush it to file. That file is now up to 1.5 megs, which is our maximum file size, at which point we'll create a new file. And we'll archive that old file And the maximum number of archived files is 4. So we'll keep up to 4 archived files plus the one that we're currently writing to for a total of 5. Those 4 files plus our current one before we then begin to delete the oldest SARM file and create a new one. You can set that SARM max number of files as appropriate for your environment as well. Your SARM threshold with the smallest response time written to our logs in milliseconds. The default is 0, but you may say, I really only care about long-running transactions, and we really need to try to find a needle in a haystack over here. I'd like to find as many of the slow transactions as possible and not get bogged down in the details. Be careful with this. That could, if you're not clear on what the data represents, you could inadvertently find that there was one particular process. Maybe we were going to a view that had a lot of different queries that were being performed, or a lot of MVGs in there that didn't have primary set up correctly, or something else that could be causing problems, maybe in a script or some special type of app like a chart. If we were looking at some of those things, we might see that there's a lot of SQL queries that are being executed. But each one of them, in and of themselves, is very quick. And so we might say, okay, we have this slow applet, now what? And because we're not capturing all the little transactions underneath, we may not have a lot of good detail to work with. And so really want to be careful that we're not trying to use that instead of doing our due diligence over there. Lastly, and this may be useful, SARM users allows us to capture a comma-deleted list of one or more user IDs for whom SARM is enabled. So in other words, I can say, you know what, I don't want to use this in production. I don't want to have this impacting all my users, but I will say whenever admin logs in, I want you to enable SARM. And so we'll set the SARM granularity level to 2 for just admin. I'll log in, I'll click around, do a bunch of stuff, and then we'll turn it back down to 0 again, or turn it back down to 1 again, and remove that list of users. And from now on, everybody will be using SARM for kind of that base level transaction gathering. And the nice thing here is if I, using that common delimited list of user IDs, I can make sure that only the users that I'm interested in, especially in a QA type environment where we're trying to figure out exactly what's going on. Just right now, I only want to walk through a test case. I can say only for this user who's logged in will I be collecting SARM data. Now, what that would look like is I was clicking around in the application and doing things. I think it's useful to kind of walk through just a mini case over here. I don't want to walk through a real case as we're trying to do a detailed troubleshooting of a specific scenario. And we do have a little bit of that coming up. But I do want to just kind of go through a very quick scenario where you could take a look at the activities that you might see kind of on a day-to-day basis in the application just to get a comfort level with what this would look like. And so what we've got here, I'm just going to navigate over to the personal service request list view, or the My Service Request view. Then I'm going to drill down on a record, and then I'm going to create a new record. And so we'll start out with our SARM case data over here. The user drills down on the link on the service request homepage, and it brings them over to the personal service request list view, or you and I know it as My Service Request. Now, from the service request homepage to the service request list view over here, My Service Request, what does that transaction look like? Well, right now I'm on the homepage, and you can see here in my transaction that I was looking at my applet. It's called the Service Request Home Public and Private List Applet on my homepage, and when I was looking at that applet, I said, SWE or Siebel Web Engine, I wish to invoke an applet method. The detail now for that is which method. Do you remember I talked about the area, sub-area, the instance name, and the detail? This is the detail. Which method am I invoking on my applet? And the answer is drill down. In other words, I'm clicking on a hyperlink. So it says, okay, you're clicking on a hyperlink. All right, that's good. We can now drill down for you. Now, where are we going? Well, SWE page. I need you to build a view. Which view? The personal service request list view, or the My Service Request view, as you and I know it. And more specifically, SWE page, we're going to be building an applet for the service request detail applet, and building another applet for the service request list applet. And so we built these two applets, the list and form applet below. Next, we go in there and create a new service request. So I go in here, I click on the new button, or I right-click new record, or click Control-N. And when I do that, I say I want to create a new record. You'll see, if you look at the help file record, the row ID 1-21 KBN3, not the SR number, which is actually a numeric representation thereof, but instead 1-21 KBN3. You can see with the new records I created, and possibly filled in some other fields. Well, when I look at my transactions, I I can see over here that once I got over here, once I looked at this thing, it brought me over to Invoke Applet method on my service request list applet. And we said, let's get to this position on row. In other words, let's put the caret next to a record. And before I could do anything with my data, my service request list applet has to know of the records I'm looking at, which one is the currently highlighted record or the currently selected record. Even if there's no records in the list applet, we still need to understand kind of where the cursor goes. And so you'll see that position on row method being invoked on my applet a lot of times before other transactions, which in this case, I invoke the applet method of my service request list applet called new record. Now, and it's worth noting, that means I clicked on new up here, not down here in the farm applet. I clicked on new in the list applet because it says that in the service request list applet, I invoked the method called new record. And when I did, my object manager then responded by saying, okay, let's have our business component create new record. Which business component? The service request business component. And the detail is that 1-21 KBN3. That row ID I told you to take note of earlier. 1-21 KBN3 is going to be the row ID of the new service request we created. From there, I fill in some data, I click around, and note that those transactions, aside from the database calls that are being made to get the data, those transactions actually are not being reported over here. And that's because those things aren't happening up on the server side. The server doesn't know where a user clicks in a field, when they start typing on things, or when they click on a drop-down. The server only knows when the server has to get data. And in a lot of cases, your object manager has really tried to cache as much information and pass it down to the browser as possible so that we don't have to have a lot of round trips. Because browser up to web server, up to Siebel server, and back down to web server, and back down to browser, that round trip time can be non-trivial and can really impact performance. And so what we want to do instead is we want to have as much done in the browser as possible. And so some of those things that a user might be doing, that's how long does it actually take them to click in the field and type in the account name or to type in the name of the service request or description and some of the other actions they may have, we don't really capture. I do have a start time for the time that the user clicked on the new record button, and then a start time and end time for when they click on save record or write, ultimately when they stepped off the record or tried to perform some other transaction that caused us to step off the record ultimately. I know how long it took before the record was saved, but the browser really is handling a lot of that work, and that is not necessarily captured back up to the SARM file over here. From there, I can see that we've invoked the applet method, service request list applet, write record, or we're saving the record 1-21 KBN3, and I can see what the throughput time was. I can see the response time in milliseconds for each of those transactions and so on. And by the way, these response times here, where it's taking a fraction of a second to perform each one of these all seem to be within reasonable KPI or key performance indicators. If you're going to take a look at what really constitutes a slow transaction, a lot of times we might have key performance indicators that are in the 1 to 2 seconds for a sub-transaction, like how long does it take to query for this data or to return this data, or maybe 3 seconds for how long it takes to build this view would be a reasonable amount of time. Really, how long it takes before your user says, geez, this view is it never loads. It takes so long every time I go here. And so it's kind of as a ballpark, that 3-second rule is not a bad one. It's certainly an unofficial metric, but it's not a bad one to work with. So that's kind of what the transactions look like. Now let's take a look at how we can then use SARMQuery to try to troubleshoot a performance issue that may have occurred. I mentioned before the SARMQuery is really our primary tool used for SARM analysis now. And it's because of those SQL-like tools that we can use to kind of query through that SARM data. It's because we can quickly slice and dice and analyze that data in a more meaningful way. It's also because it's platform independent. And we can look at SARM data files, whether they were generated on a Windows box or a Unix box. Those are just binary files, just ones and zeros that are being written out, not formatted. There's no character set or code page conversion issues we have to work with. We're just dumping a buffer straight out to file. And so SARM really doesn't care where it was generated or how it came in. Instead, it quickly reads those SARM files and performs some basic manipulation on them. It can also do some CSV conversion for us before we dump data out. That's a lot faster than going into a spreadsheet-type program, especially because a lot of spreadsheet programs can't show more than some certain number of transactions, whether it's 100-something thousand or some number like that. We may see that there's a cap on the number of transactions that we can actually view in a spreadsheet program. When we instead perform a quick pre-analysis of SARMQuery, we can either quickly find stuff without ever having to dump data out to CSV, or alternately, we can trim down the amount of information we ever push to CSV so that we're only looking at the stuff we're interested in. Now, with SARMQuery, I mentioned before, this is part of the Siebel server installation for Siebel 8. SARMQuery.exe is located in your bin directory on your Siebel server. It can be run from the command line. You can also add that SARMQuery directory as a path system variable. And so you might put in, for example, C:/SEA80/SeedServerBin or SEA81/SeedServerBin, wherever the server was installed. If you've not installed it in the default directory, maybe it would be C:/OurSiebelHome/SeedServer/bin, or in a Unix environment, certainly the Siebel home might be totally different. Now look at this, though, that SARMQuery tool can be run, and it runs with 4 main things that it needs for inputs. When you run SARMQuery, you need to tell it, okay, which SARM files am I going to use? First things first, it needs to know what am I going to be loading into memory. Now, in those SARM files, there are a lot of transactions. Which data do we want to include from those transactions? What processing should I perform on that data? Should I filter the data in any way? And where should I output that data? For that, we can use SARMQuery-help to try to understand what those are. And it'll bring back a list of the option flags that we can use. You might remember me doing, for example, SARMQuery select tree equals all. You might remember some of the stuff I was doing before when I showed you a quick run of SARMQuery as we dump data out to a CSV. In this case, SARMQuery-help. We'll just dump out a list of the option flags. And you might see, do you have things like SARMQuery-select or -help or -something? And when you type those in, you can actually, instead of SARMQuery-select or -help, you can type in SARMQuery-HE. It says, well, HE, there's only one thing to do with HE, and that's help. So that's the help screen. However, SARMQuery-H is not unique because there's both -histogram and -help as options, and so you can't use that. It's not clear enough. But SARMQuery is smart enough to know when you're trying to trim that down, which may be helpful for some power users. Here's an example of what SARMQuery-help would give you. It gives you a quick description. SARMQuery is intended to do this. SARMQuery-options with your input specification. And then here's all the information you need about it. You can see a bunch of documentation that's pushed out when you run that help. I find actually SARMQuery-tips to be even more useful, though. What that'll do is I'll just give you some example statements. Like, for example, let's do SARMQuery, and then give me the directory where we've installed our SARM files, or we've got our SARM files. And then let's aggregate that data by area. And so that's a quick performance fingerprint at a glance. We'll actually run that one in a moment. Or SARMQuery-select area BBC. So we'll dig a little deeper into our database calls, it says. So let's select area of BBC and then aggregate by sub-area. And we'll do that too. So here, we have a performance issue, and we see that we have view. And it's taking longer than 3 seconds to build, so our users are starting to complain of slow performance. We said, okay, we need to do something about this. And maybe we have in the call center, we have our transactions are taking longer than they're supposed to, or our call center agents are having difficulty providing information out to the customer in a timely fashion. They find themselves stalling a little bit, and they're losing control of the call, which means that the customer ends up starting up a new line of conversation, and it's really impacting our numbers in a bad way. Whatever it might be, we can see a lot of statistics are kept in call centers to try to improve these things. And we've decided that 3 seconds is our key performance indicator for how long it should take to go to this particular view or work with views in our implementation. Now we want to use SARMQuery to try to figure out why is this view taking longer. Now, 3 seconds, 3.5 seconds, 3 3/4 seconds, that might not even be the issue there. We're looking at something that's taking a lot longer than that 3 seconds. And in fact, in this case, we are. When we go in here, we can run SARMQuery, and we can first tell it what we want to pull out. Now, when you run SARMQuery, it's going to perform a couple things. The first thing you need to know is where's my data. And so here, in OUSCA seed server log, we've got some log files. In our log directory, we have not only our log files, our Siebel server and component log files, but also SARM files. I'm going to run SARMQuery against that whole directory, SARMQuery dot, which says go to this entire directory. You may have seen that nomenclature before. In this case, SARMQuery dot is going to say load all the files in the memory. It says, okay, well, there's 6 input files. There are 6 SARM files in that directory. And in fact, this one was empty over here. There's no duplicate files. There's 5 non-empty files. And you can see over here the total size is about 38 megs worth of SARM data. So there's a lot of stuff in here. Here's the earliest data, the minimum buffer size, maximum buffer size, and all sorts of information about that. And yeah, we were able to load those SARM files. So very basic thing that you can do. But I'm interested in more detail. So one of the things I want to do is I want to look at the data inside and perform an aggregation. And what that is really just kind of a sum total or a subtotal that we're going to perform against something like the instrumented area or sub-area in the application so that we can quickly find how long is it taking to perform these types of transactions and those types of transactions and break them up into meaningful chunks. And so for our aggregation over here, I'm going to say let's run SARMQuery and let's input dot. Now in this case, I'm looking here in my SARM data files directory. We can install our SARM tool /SARM/data files, and this is where I'm plunking all my SARM files. So the example that we're working with here. And we're saying SARMQuery-input dot, and it says that we're collecting 4 input files. So there's actually, we didn't just get one SARM file here. We collected several SARM files. We want to look across all of them. And that actually may be useful. Remember that when we're collecting our SARM files, we're looking at the transactions across all the different users who've been logged in as we had a buffer of a half a meg, and then a meg, and then 1.5 megs, and then we flushed the disk. So there's our first file. Another half meg, 1 meg, 1.5, and we flushed the file. Well, after we got 4 of those files, we said, let's put all those into this output directory, and then -input dot. So we're just going to run it against that entire directory, and we'll aggregate that by area. And so it says, okay, let me look at all those transactions, and I see that of those, 51% of our calls were database calls. So the 47% were sweep page calls, so they were building some type of view or applet or other user interface object. Simple web engine calls or infrastructure calls really weren't taking a lot of time. Scripting and object manager calls, like a business component level transaction or workflow, those things weren't taking as much time. There were some transactions in there, but most of our time we spent on database calls and sweep page. Now, is this a healthy percentage? I can't tell you that. Just by looking at these files, I don't have an idea of what's normal in your environment. And that's why I said before, it's probably a good idea to try to run SARM in the background, just kind of on that level 1 in a production environment, even if it's not all the time, just to get a kind of a baseline of what's normal so that you can try to find any outliers more quickly. But over here, I see 51% of our time is on database calls, 47% on sweep page, and the response time on these is pretty substantial. I mean, when I first looked at this, it's 1,634,000 milliseconds. So out of these SARM files, they apparently total up to about 3,000 milliseconds or 3,000 seconds, I should say, which is about 50 minutes worth of transactions. So about 50 minutes or an hour worth of transactions we collected data for. We can see how much of that time total was spent on database calls, and it was about a half hour worth of database calls in that 50-minute worth of SARM files that we collected. So it sounds like a lot. But again, is it? I have nothing to compare that to right now to be able to say that this is a long time or a short time. And that's one of the reasons, as I said before, a good idea to try to get baseline data. But from there, we now want to filter in there and try to figure out, are there specific areas where this is slower than it should be? And so I want to try to filter that down and say, okay, I'm only interested in certain of this data. I'm only interested, for example, in my database calls or sweep page calls. And so what I'll do is I'll filter my data very much like a select statement, and I'll say select host equals name, or select start time equals this, and end time equals that. So give me everything from this time to that time. Or only look at area equals database calls, or area equals sweep page. Or only look at sub-area equals, or whatever it might be. In your SARMQuery reference manual, you can find a lot of good information in there. You can also find in the Siebel Performance Tuning Guide and bookshelf, there is a lot of comprehensive documentation on how to use this tool. The problem is that nowhere in that entire manual does it actually say the word SARM. Instead, it's called Siebel ARM in that document. And so it's worth noting that in the bookshelf, documentation on this, or in the documentation called the Performance Tuning Guide, you will find that the Siebel ARM is the name that we use for the tool I've been describing here is SARM. I don't know why, but it just doesn't call it SARM over there, and so worth noting if you're trying to find it. In this case, though, I said, okay, well, let's first take a look at our SARMQuery data. Again, we'll input all 4 of those files, and I want to select area of sweep page. I want to look at the sweep page transactions, and we'll aggregate those by sub-area. And I can see of the time that we spent, 99% of our time was spent building applets, not building views or displaying those views into a renderable web page, but instead we're building applets. Again, is that normal? Is that how it usually runs? I can't tell you that without understanding the baseline data that you're working with. You may have substantial transactions that are taking place, but for good reason on some of these things and not on others. There may be script or some type of configuration that you've done that would cause some of those numbers to look differently from how they would in another customer environment. From there, we might say, okay, let's produce a histogram. And a histogram is an aggregation not by type, but instead over an interval. And so what I'll do is I'll say, I want to know from response time or self-time or CPU time or whatever it might be. I want to do a histogram, and I want you to show me everything that took less than a second, or between 1 and 5 milliseconds, or between 5 and 10 milliseconds, between 10 and 20, between 20 and 50, between 50 and 100, between 100 and whatever. You know, if there's nothing after that, then it's anything over 100. And so in my case, I'm going to say, let's take a look at our sweep page applet builds. Again, SARMQuery, we'll look at all of our data. We'll select the sub-area of sweep page applet build, since that was the one that took a long time. And we'll look at our response time, and everything that took a tenth of a second or less, I can probably throw out. You can see 96% of our transactions took a tenth of a second or less. Anything between a tenth and 2 tenths and 5 and a full second. Here we have 1 second and 2 seconds, 2 seconds and 3 seconds, or more than 3 seconds. Well, over here again, I can see that there's a small number of transactions. There's one call that took less than half a millisecond, or less than half a second. I don't really care about that one. I have 2 that took between 1 and 2 seconds. Again, more interesting, but still not the problem. I have 6 of them that took between 2 and 3 seconds. Again, that may be the main issue over here. But I see 3 of them that took more than 3 seconds, and those are the ones I'm going to look at first. I'm really interested in the ones that took the most time, and so with the histogram, I can kind of ballpark what would be my level of interest in these different things. I might say, you know what, instead of looking at anything less than a tenth of a second, let's look at anything less than a full second, because I don't care if it's a tenth of a second or 2 tenths. And so I can kind of define what I want my histogram to look like based on the type of request that I'm making. In here, we then have remember that whole SARM call tree. Remember the request is not confined to a single SARM area. And so I'm looking at my SARM call tree. I might see that there's an infra call, a call made into my object manager, which then we can split into the Siebel web engine call as we're going in there and saying you need to render this request in some way that the clip they performed or the view they wanted to go to, as well as an object manager request, like, for example, the business component transaction, or maybe we call it script, a database call where we're performing a fetch. A script might have called the database directly, and maybe invoked a workflow that did some EAI stuff. You can see there may be a very complex chain of events that are coming in from a single transaction by the user. And we're interested in navigating that tree. So I take a look in here and say, okay, let's look at our sub-area of sweep page applet code. Let's look at everything that has a response time of 3 seconds or more. And so select response time equals 3,000. We'll bring back everything with 3,000 or more. Then we'll do dash select tree equals parent. And what that does, the select tree equals parent allows us to see everything that is the parent of those long-running transactions. Those transactions that took more than 3 seconds. And so I'm looking at my applet builds, but I'm interested in the parent of those applet builds, and we'll aggregate those by instance. And you know what I see? I see that all of them came from the homepage view, EVM, whatever that is. That homepage view seemed to be the problem. And that homepage view really wasn't taking that long itself. The time it took just for response time was probably low, but when I take a look in here at the more detailed layer, there are a couple of applets on there, and those were taking a lot longer. And when I say a lot longer, this one took 736 seconds. Not 736 milliseconds. 736 seconds to build the Project Gantt Chart AX applet on my home page. Now, what is that applet? I don't know. It's a Gantt chart applet of some sort. What is a Gantt chart? Well, it's some type of chart applet that was built in Siebel. And what happened in this case, as I take a look at this, is it took 736 seconds and 729 seconds to build the other one. I output that at the CSV, and I can take a look in here, and my sweet page applet build, and I can see that Project Gantt Chart applet took 723, 729. I can see these long-running transactions over here, and my poorly performing applets. So where are these coming from? And I see underneath all of these DBC prepare, execute, and fetch statements. And in fact, there were so many of those transactions. What was happening was somebody had misconfigured these applets. And what was happening was that they were sending just massive numbers of queries back and forth to the database, trying to be able to resolve the data that it needed for the x-axis, the y-axis, type of stuff they would have in a normal chart applet. But they'd misconfigured it so it wasn't bringing that data back properly, or it had some type of recursive relationship to the data we were trying to pull back. And it ultimately caused huge performance issues, and we couldn't figure out why it was ultimately hanging up when they went to these applets. What we could see here was it was clearly these applets that were the problem, and there were a lot of database transactions underneath. But we couldn't tell what went wrong. And that's the key piece. I want to make sure you guys are aware of this. SARM is not a tool for trying to figure out how you misconfigured something. It's not a tool for trying to figure out what checkbox you need to check or what field you need to change. It doesn't talk about that type of stuff. Instead, all SARM is doing is capturing our transactions in a logically structured way so that we can quickly query through them and try to find the poor-performing transactions and their predecessors so that we can ultimately, very quickly, try to find the problem in the application. And that's the key takeaway over here. If I'm trying to isolate that one slow piece of code and trying to figure out where in the application, which one or several places I need to look to get more quickly into our performance troubleshooting, SARMQuery and SARM really give us a fantastic tool for that. If instead I'm trying to figure out how to fix it, well, that's a whole separate conversation. I can go into my logs, look at the SQL, marry that SQL back up to the SARM ID, the slow-performing transaction. Each one of these SARM IDs might then be in my log file as I'm capturing my Object Manager SQL log. I'm capturing all the SQL that's being spooled out there. I can see why those things are happening by looking at the SQL itself. I don't get that in SARM. But what I do get is a very quick way of finding where that slow-performing transaction came from. And so I mentioned before, having baseline SARM data. If you walk out of here with nothing else, the idea that you want to try to measure some baseline for your implementation, get a feel for what things should look like so that when you have a problem in production at some point in the future, you can then look back and compare it to what your baseline data was and say, okay, this looks normal, this is normal, this is the piece that's out of whack. And if you are going to implement this in production, you can, by enabling that SARM level of 1, it has a minimal performance impact on the application, but you shouldn't be enabling SARM level 2 in production. It's nice to have that record normal behavior, but turning it to level 2 would cause performance impacts to the middle of its own. So I want to say thank you to everybody. We do have some questions over here. I do want to offer some time for Q&A. We did talk about how SARM works, how to enable SARM in the environment, how SARM files are written and how we can look at them. We talked about what the actual data looks like in the data structure. And then we talked about SARMQuery. So a lot of good stuff in here. I know we could go a lot deeper into some of these areas, but in the time frame that we had, I really wanted to make sure everyone in here was aware of the tool. I said before, and I'll say it again, if I could pick one place where there's just a fantastic amount of instrumentation, this really powerful tool for quickly finding things that would be helpful both to you guys in trying to troubleshoot your own issues, but also in trying to provide information to our support team as well. If you do have an issue and being able to provide that performance data up to the good folks in the Siebel support team, make sure that they have access to the same information that they can use to try to troubleshoot. These can really give us a huge leg up on trying to solve performance issues and really get us home a lot quicker. So I want to say thanks again to Sharonda for getting this started and Tara as well. So I will get us going with Q&A.
All right.
Go ahead.
Thanks, Fred. We hope everyone found the presentation very valuable. We'll open it up for Q&A in just a moment. Please use the chat feature or phone lines at this time to post a question. Tierra, can I get your assistant Can you please give instructions for posting a question via the phone line to our audience, please? Thank you.
If you would like to ask an audio question, simply press star, then the number 1 on your telephone keypad. We'll pause for just a moment to compile the Q&A roster.
All right. While you are doing that, a couple of notes I want to forward along with you. Within 48 hours, the download streaming link and the PDF file for this presentation will be posted on my Oracle support. The doc number for this is 740964.1. I will post this in the chat window for you in just a second. As a reminder, if you think of a question after the presentation ends and you've had a chance to go back and view the recordings and you have a follow-up question, don't hesitate. Please send me an email, sharonda.pettit@oracle.com. I'll post this information to the chat for you as well, and I will forward all your questions to the presenter to answer on a one-off basis. All right, Tiara, do we have any questions from our audience?
There are no audio questions at this time.
Okay, then I have quite a few on chat. So let's kind of read through these questions. Question 1. Can we use SARM like an alert crash dumping file application? For example, a bad practice in scripting is not clearing the memory variable. Is there a way to configure SARM to act similar to this?
The quick answer is probably not. The tool is intended to try to capture the transactions. It will capture transactions related to scripting, so that it can try to take a look at both the memory and also the response time and CPU information that are tied to a particular transaction. And a scripting transaction, it could very well indicate that there is some type of issue, but getting into the level of granularity of tracking down the variables, that's not handled here. Trying to track back to that, a lot of that is not actually logged out by default with SARM or really in any other place that would capture that. However, we do capture things like your assert errors, and I saw you with the crash dumping file you mentioned there. If you do have a crash in the Siebel application, which it certainly can happen, especially if they have a poorly configured script that we've written manually against it, then what we may see is that a crash.txt file is generated, and if you look in that crash.txt file, you may see an assert failure count that indicates those types of issues. When we start to see bad practices in scripting, like you said, unhandled errors in particular, those asserts that may be happening along the way may actually increment by 1. So you may see an assert failure count for kind of a normal transaction where something just happened. Maybe we picked off a virus scan on a machine that was already way overloaded, and next thing you know, everything just suddenly went haywire and something crashed for some reason. If you were looking at something like that, you might not actually see a high number of assert failures that were going on in the server. Instead, there were other things that indicated a problem. However, if it's scripting or similar types of transactional issues going on, we might see a very high number in there. So that may be a good way to try to track that down. But no, I don't think SARM is going to look at things at the level of granularity you're describing for scripting.
Thanks, Fred. All right, I have another question for you. I actually got a couple. Let's see if we can get through them. If we get 4 SARM files for an issue, do we have to analyze all 4 files to understand the entire issue?
That's a good question, too. The answer is sort of. The 4 SARM files that you're getting, most likely, what we've got is we've turned up the amount of SARM logging that we're collecting, so that we're collecting up to 4 files, and so we're collecting the current file as well as the last 3 or 4 archive files that we have, and so what we're getting is not just 4 separate files, but instead the 4 total files that include all the transactions from the last 10 minutes instead of 4 files that are each for the last 2.5 minutes. Or it could be that there's so many transactions that are being generated in there that instead of 2.5 minutes per file, you might see that there's really only like 30 seconds worth of transactions per file or a minute per file, especially if there's a lot of users logged into that box. And so it may be worthwhile to look at all 4 of those just so that we can get a comprehensive list of the transactions that were going on during the time frame that we were maybe performing a task or that we were observing the bad performance. And so when we're looking at that, you want to be careful not to only look at that one last file, the one most recent file, because you might not actually have the poor performing piece of functionality in that one file. So now you go in there, you try to figure out what was the slowest thing in this file. And the answer is some arbitrary thing that actually isn't a problem at all. And you say, well, geez, it must be that. And it's kind of a false positive that you found in there because you're looking at your SARM file at the most recent one, and you're not looking at the file that actually contains the issue. So probably a good idea to look across those files to understand the entire issue. If you have more than the one, then you need to look at all the ones that are recent, unless there's a single user environment in dev or something where we have a little more granular control over to make sure that there really is no need to look at anything older.
All right. Question 3. How would a SARM capture events related to the CPI toolbar? We see a lot of issues related between Siebel and Avaya IC, and seems to be performance related. Would SARM trace those connections all the way back to the Avaya server so we can look at the whole transaction?
Yeah, that's actually a good question, not only for integration with CPI, but really any type of integration with some type of other platform. You know, if we're talking out to, for example, if we're integrating with Fusion middleware or WebLogic, WebSphere, any of the integration middleware that you may see out there, or if we're talking directly to a target application, if we have some type of XML-based or web service-based integration or some other type of integration as well, there's going to be a cap on what we're collecting data around. And what we have in those transactions, SARM is integrated into the Siebel component architecture. So in your object manager component, we might see that. Other server components related to that, like, for example, your COM server component, I'm blanking on the name right now, or your MQ series receiver, or any of the transactional components that may actually be handling the integration that we're doing with something like Avaya or with something like a middleware server. In those cases, those transactions, if we can capture where they're happening within the Siebel sphere of control or where they're happening inside a Siebel component, but we're only capturing data for those Siebel components. And so we can see the transaction as it leaves the object manager, as it arrives at the next Siebel component on the chain, and then as it leaves that component and goes over to something else, we can see the departure, but we can't see anything that happens outside of that. We wouldn't see, for example, what was going on in Avaya. However, in Avaya, we may have access to other transactional data that may be similar to or somehow marryable to the SARM data that we're looking at, and we can look at those transactions internally to it. However, when we're trying to look at those transactions, what we can see is what the round trip time is. How long did it take after it left the last component in Siebel that was running SARM? We can look at the last transaction as that exited here, and then how long it took to come back. And that can be a useful idea to try to figure out where our bottleneck is. It doesn't help us to isolate what transaction in that external component, whether it's Avaya or certainly any one of our Pine partners out there or other Oracle products that we might be working with. And one other external thing, we can't isolate where in that external thing it is, but we can figure out, you know, it took a fraction of a second to get out of the object manager. It got directly over to the other server component that we were using in Siebel, which then sent it out to that target application. Everything went smoothly, but then we didn't hear anything back for 5 seconds. Well, now we have an idea of where the bottleneck is, and it's most likely over there, or in the throughput time it takes for us to send it to them. So that's the best I can answer for that is, you know, we can see what we can see. And, you know, SARM is only going to collect data for the Siebel application. I can see another one in the chat. Sharonda, if you don't mind, I'll jump right into that. The max number of SARM files are created with the first file get overwritten by the next one. I wanted to jump back over here. I think I can go right back to the slide where that was happening. We actually talked about something like that. And so when we go to write that, one active file, and you can see that once we get up to the, I apologize as I'm going through this. Here, when the maximum number of files limit is reached, we do delete the oldest SARM file and create a new file. And so it's that SARM max number of files parameter that allows us to control that. So very good question there.
All right. Good one. Tiara, I'm going to check back with you. Do we have any questions on the phone line at this point in time?
There are no audio questions at this time.
Okay. We have just a few more minutes. I'm going to see if I can drive through a few more questions here, Fred. I'm going to go about another 3 minutes or so. Another question, number 5. Can we measure the performance issues can we measure the performance issues caused by client-side scripting?
Well, again, it's the same issue I talked about before, where we can see the time it takes for the script to run. We can look at client-side scripting, or we can look at scripting that's run there if we're looking at on the client machine. However, when you say client-side scripting, there's really 2 things you could mean. There's script execution on a sick client, and we can enable SARM on a sick client to look at that. You can take a look at the transaction of that processing and everything else. But there's also the browser script. If you're talking about bscript or the JavaScript that we can implement along with thin clients so that we're actually executing browser-side scripting on the client machine, that type of transactional data, although we can capture the throughput time of the bscript, and we can actually see that on the client machine when we're enabling that SARM on the local file. We do have some kind of a black box from there into how long the browser is taking to execute some of those transactions. Because again, remember that SARM is only looking at the time that it's taking for things that are being handled by Siebel components, whether it's the call center executable, the object manager server component, the Siebel server or web server extensions, or whatever object it is. There's a cap on how much of that data we have. And so I'd encourage you to take a look in there and see if you can capture the level of information you're looking at. But yes, we absolutely can see that it'll actually show up, I believe it's a bscript execute event that's being called. The bscript execute will show up as a transaction in there, just like your database calls that I saw before, or the sweet page applet build, and then the name of the applet. It'll tell you the name of the business, the browser script that's being executed. But it stops there, and it doesn't tell you much more about why it was slow or where in the script it was slow. That part, you'll still need to do the old-fashioned way. And certainly one of the ways to do that is to use the Siebel Tools environment to kind of do the step-through, step-into type execution as well. When you're looking at scripting, whether you're looking at browser or server script, it may be helpful to kind of click through it that way to try to track down those issues. Good question.
Okay. Here's another question. Looking like the same question for me, so hold on one second. What's the difference between the self-response time and response time? And then it looks like there's a follow-up question regarding the percent self-time and percent increase response.
The response time versus self-response time. Response time is going to be the total response time for the transaction. So the user clicked on something, and ultimately, it was the thing that caused us to feel the personal service list view and these detail and list applets over here. In other words, they navigated it in some way. Now, how did they navigate? They might have clicked on a hyperlink or drill down. They might have clicked on the drop-down arrow to go to my service request. However it was, they navigated. That transaction came into the web server, which then handed it off to the object manager, and the info entry, the moment that came in, we said, hey, admin wants to do something. So he received the call. Now, the total time for that was 1.452 seconds. However, the actual time it took for us to say, admin wants to do something, was only 3 milliseconds, or 2.948. There's only a fraction of that time. So the self-response time for that transaction was very small. But the total response time for the transaction of them saying, hey, I want to go to this view, was 1.5 seconds. And the reason for that is there's a lot of pieces that make up that total response time. There's going to the view, there's building your applets, there's querying data from the database to populate the applets, and so on. And so the response time is this total of all the self-response times of all the things underneath it. As for the percents, and the percent self-time, percent inclusion response, etc., that, I believe, is I actually don't remember percent self-time. I don't think I've ever used it, honestly. I know things like percent CPU we'd certainly see in there, but I don't remember using percent self-time at all. Again, percent equal rest, I don't think I've used it either, so I can't really speak to either one of those off the top of my head. I'd have to punch over to Bookself to try to get an answer off of that one. It's a good question. You've been doing your homework, I see.
All right. Tiara, I'm going to check one more time. Do we have any more questions maybe coming over the phone line that we can address?
There are no audio questions at this time.
All right. Thank you so much. And I think that covers all of our chat-related questions as well. So due to the time, I'm going to go ahead on and close out the Q&A session, but I do want to thank all of you for your questions. Those were great questions. Fred, you did a tremendous job answering them, so thank you so very much.
Oh, thank you.
All right. Fred, can I get you to transition to the thank you slide so I can thank everybody for attending today's web conference? Thank you, dear. Well, thank you, Fred Hebert, and thanks to everyone for joining today's Oracle Advisor webcast. We hope you found this webcast valuable, and we do look forward to you joining us again. Please enjoy the rest of your day. Thank you. I will post my email address here in the chat box for you in just a second, along with the doc number information so that you can know where to find this recording once it's posted within the next 48 hours. So I'd like to thank everyone for their attendance today. Along with the folks that are supporting this web conference, Tiara and Gabrielle, I thank you as well. That ends today's Advisor webcast. Thank you.
Thank you, ladies and gentlemen. That does conclude today's Advisor webcast. You may now disconnect.